So we're going to be finding the derivative of an inverse trigonometric function, namely the arcsin function. So recall the definition of the arcsin function is y is equal to sine inverse of x, which implies that sine of y is equal to x. Also recall the range of the arcsin function. It's negative pi over 2 is less than or equal to y is less than or equal to pi over 2. So let's implicitly differentiate both sides of this equation. So we have d dx of sine of y is equal to d dx of x, which implies since the derivative of sine of y is equal to cosine y times y prime using the chain rule, we have that cosine y times y prime is equal to 1, since the derivative of x is just 1. Now let's solve for y prime. We get y prime is equal to 1 over cosine y. And recall that sine squared y plus cosine squared y is equal to 1. And if we subtract sine squared y from both sides, we get cosine squared y is equal to 1 minus sine squared y. And taking the square root of both sides, we get cosine y is equal to square root of 1 minus sine squared y. But sine y is just x. So this is equal to square root of 1 minus x squared. And we could plug this in back into our equation for y prime. And we get that y prime is equal to 1 over square root of 1 minus x squared. And that's the derivative of the arcsin function.